Yeah, so my name's Cody Bailey. I'm the Chief Science Officer on board the Marcus G. Langseth. Everybody can still hear me, right?
Yeah.
All right, good, yeah. So, yes, this is on a research boat, so we could have internet problems. We are working right now, so someone could swing by and say hi, ask questions. That's just the way it goes. Yeah, so is by Columbia University. And right now we're transiting south from the Cape Verde Islands, going down to our work area. So when a boat transits, so we go about 10 miles an hour, 24 hours a day, and we transit that entire way down to our work area. So during that time, we have various type of jobs we do on board, maintenance, different things with it. So you can see all the screens behind me. So we upgrade the software, we upgrade the firmware, and a lot of different maintenance and things like that we do on deck. As we also transit, so we take data as we go, or we acquire data. So we have a couple different sonar systems running. We have the EM122 multi-beam. We have another sonar, a chirp, and an ADCP, which is a current profiler. So that's a lot of terminology, but basically what we're doing, we're making a map of the ocean bottom as we transit along the ocean. So there's a program called Seabed 2030, and their main mission is to have all the seabeds mapped by 2030. So we're a long way from it. So we only have about 26% of those oceans are actually mapped right now with high resolution multi-beam data. So when you look at Google Earth and it shows sort of the ocean bottom, that's merely some of the data, but a lot of it is just sort of extrapolation based on the real data, but also based on sort of some satellite data acquisition. So essentially what they do is they shoot a radar beam at the surface of the ocean, and they measure sort of the topography of the surface of the water. And through that and other type of measurements, gravity, etc., they can sort of make a approximation of what the bottom of the ocean looks like. So let's have a look at Google Earth here. So right now you should see the shared screen. So hopefully this looks familiar. Hopefully it's where you're at right now. So as we zoom out, so we come to obviously the Michigan. Yep. So Michigan, and then keep coming a little bit farther out. Doesn't look like it likes Google Earth today. It's a little bit strong. So if you can still see the map, which I believe you can, so you can see the eastern seaboard of the U.S. Here in the center of the screen, we have the Mid-Atlantic Ridge. We have the Cape Verde Islands, which are right in here. That's where we just came from. And then the Langseth is this yellow vessel track. So for some reason, Google Earth has taken a long time to sort of zoom in. So I don't really want to move it too much. But you can see the boat. This is the Marcus G. Langseth. We're going south towards our work area, which is down here. We'll give it a little bit second here and see if it can come in. We went, so we sailed from Savannah, Georgia, March 1st, and we went to Cape Verde Islands. Let's see if we can zoom in a bit more. Yep, there we go. So we sailed from Savannah, Georgia on March 5th, on 1st, and we spent 2 weeks at sea to get to the Cape Verde Islands. We were there for a day or two, and then we started to sail down to our work area. So if you remember from your science class, let's put the plate boundaries up. So we can see, so I just added a layer that has the plate boundaries. So you can see the green is divergent, red is transform, and blue is convergent. But of course, we know the Mid-Atlantic Ridge here is a divergent plate boundary, right? So the Atlantic, we have seafoam spreading there. And then in the red area is our transform fault. So what we're going down to have a look at is down at this transformer fault right here. So this would be something similar to what we see, for example, in the San Andreas type fault. So it's this red area that we were looking at. But what I wanted to show you is the seafloor data. So when you look at the data, you can see this is sort of it's blurry, it's not very defined. Where if you look up here, you see sort of a track which has better definition. You have a track here which has better definition. There's a couple down south here. So the areas with the better definition are the areas that have only actually been mapped with sonar, so we actually know what's there. This other area that's blurry or fuzzy, we've never actually mapped. So, and when I say we, I mean the global science community. So we can zoom out and we can see sort of on the top here. So this is steaming south toward work area. So what we're going to do there is we're going to recover OBSs. So OBSs are ocean bottom seismic nodes or units. And they're essentially an instrument that we drop off the boat. It floats to the bottom of the ocean and it records seismic data for a couple weeks, a couple months, up to a year based on the battery life. And so they sit down there, they record refraction seismic data, and then we come back, us or another vessel, we come back in a couple months or a year, and then we recover them. So we dropped these units off in December of last year. We were here, we dropped them off the boat, and they just float down to the bottom. So the water depth is about 4,000 meters here. And with that, so 4,000 meters of water depth, it takes an hour, hour and a half for them to get to the bottom. That's how deep the water is. When we get back to our work area and we need to release them. So how do we release them? So we use acoustic instruments on board the boat. We have a transmitter that transmits at 12 kilohertz, and we can talk to the instruments on the bottom of the ocean. So we can put the frequency in for that instrument. We can then ping the instrument and say, basically, hey, wake up. And then we can range. We can get a range from the vessel to the instrument. And then once we've established the range, we can then send a command to release itself from the bottom. It has an anchor, and it releases from the anchor and floats to surface. And once again, based on the water depth, these will take anywhere from an hour and a half to 2 hours to get to surface. That's just an appreciation of how deep, once again. And then once it's on surface, then we go and we try to pick it up. So here's a little video of us deploying the OBSs. This was a deployment we did in Iceland last year. Hopefully it shows.
You have been the one for me. Goodbye, my lover. Goodbye, my friend. You have been the one. You have been the one for me.
Yeah, so fun little video there. So you saw that take that. So the yellow instrument was actually the OBS. So that contains the floats, the batteries, the geophone or the seismometer that records the seismic data, and that's up and over the side. And then here's sort of a picture of us with it alongside. Let me hold on 1 second and change the view. Yeah. So you can see the yellow item on top is the float. And that's how we bring it on board. So we hook a couple ropes up to it or a couple lines, and we have a winch and an A-frame, and we're able to essentially crane it back on board. This is a picture of a day that we don't want to work on deck. So that's a bit too much. So when we're doing this, we'll have anywhere from 20 to 50 people on board when we sail out for a seismic cruise or a scientific type cruise. And the crews come from all over the world. We'll have a couple different nationalities, up to 6, 7, 8 different nationalities that come on board. So everybody works obviously and lives in the same boat. So this is an example of the mess room on board, cafeteria style. We have a little sort of a line that we head up, get our food. This is the main lab, which I'm in now. So there's over 40 different monitors. A lot of them are off right now. Most of the monitors are on when we actually do a towed seismic job. So when we tow a cable, the cable 9 miles behind the boat, and we tow it as we acquire data as we go along. So before sort of I move on, are there any questions right now? Is that no questions?
No questions. Not today.
Okay. Yep. And other type of work we do. So as we're preparing for the jobs. So this was in Savannah. So this is the Marcus Langstaff up against the pier here. So this is us getting ready for the scientific mission. So you can see the crane going up on the top deck there. We're craning all the material over to the boat, and then and then we secure it for the seas. So this is an example. If we don't secure things well, this is an example of what it looks like.
All hands, hoist the colors high. Heave ho, thieves and beggars, never shall we die.
Yeah. So there's a lot of different people that make the boat work. You have the marine crew, so the captain, just like Star Trek, the captain and chief engineer, and you have the bridge officers. You have the engineers who work in the engine department. They go to a maritime school. You have sometimes we have wildlife biologists on board. So when we do a seismic gun, where we have a seismic source, we make noise into the water, and when we make that noise, we have to have an environmental permit to make sure that we're not harming any of the marine life. So we'll have a dedicated 4 to 5 people that come on board, and they're protected species observers. So they look for whales and dolphins, turtles, different type of seabirds. So this is a picture from them. This was a dolphin they saw. This was a couple months back. So when the protected species get too close to the boat, we then have to shut down operations until that particular animal is gone. So they have a biology degree. We have people with geology. We have people who went to a technical school to learn sort of instrumentation and electronics. So all different type of degrees on board, or technical certifications, to make sure that the boat can go out and do science work. We also have safety. Obviously, when we work on board is quite important. So we have different drills that we do on board the boat. So this was a drill. So that's the gentleman in the white T-shirt is the chief mate. So he's giving a demonstration on the life jackets, and also how to launch the life rafts at one of our drills. So all the crew goes up for the drill, and these happen every 2 to 3 weeks. It depends on what the drill schedule is, and depends on what type of drill we want to run. For example, if it's stormy out, we're not going to have a drill like this where we have to go stand on deck. So it'll be something more sheltered. We have a drill coming up for confined spaces. So we have areas on board the boat that are quite tight, and we have special training just for that, where we monitor the air to make sure that it's safe for the crew to go in. Go ahead. So talking about the plate boundaries, so I mentioned the transform fault. So a couple other boundaries that we've seen before. So this is data from the Langstaff from a few years ago. So this is on a convergent plate boundary. So on the left-hand side, you can see this is the oceanic. This is the Juan plate, and on the right-hand side is the North American plate. And you can see the plate as it subducts under the North American plate. And then I pointed out the sediment layer as well. Another one that we came across not too long ago. So this was the Mid-Atlantic Ridge. So what I showed before was seismic data. So this is 2D seismic data from our streamer that we tow behind the boat. And this is the multi-beam seabed data that I was talking about before. So on the right-hand side is a Google Earth image of sort of the Mid-Atlantic Ridge. You can see the vessel track, the North American plates on the left, the African plates on the right, and then you can see the actual image of the seabed itself here on the left. So this blue portion is the actual ridge itself where it's spreading. So it's pretty neat. Any questions about the different plate boundaries or life on board?
I have a fun time on the boat.
I'm sorry, can you please speak up a little bit?
I said, you guys have a fun time on the boat?
Yeah, you may need to either come closer.
I want to hear like stories.
They were wondering if you had any interesting stories.
Oh yeah, there's lots of stories. So this was so a lot of the fun stuff happens sometimes during crew change. So this is one of the work boats. We go out and inspect the equipment. Last year we were by the Galapagos Islands, so we worked around the Galapagos Islands for a month, and then afterwards we got off and we had a few days in the islands where we got to see obviously the tortoises. A lot of people went diving. So sometimes we go to fun places. We were just in Namibia by Walvis Bay last March. So people went out to the sand dunes and went snowboarding or sandboarding down the dunes. There's a lot of different stories. Sometimes the weather can get quite rough, when you're on board. So some people are a little bit seasick. So they always have a good story when they go home. Of course, the waves are always a lot bigger than what they probably truly were, but it's still a good story. I mentioned, so before we go to another question, I mentioned the seismic source. So that's what makes the noise in the water. So we make a noise, it goes down and reflects off the bottom of the surface and also the layers, and then it reflects back and we measure it on the cable that we tow behind us. So this is an example. Yeah, so that's the seismic source, and like I said, that's what makes the noise. It goes down, reflects off the layers, and comes back, and we record it on the cable that we tow behind the boat. And the cable's 9 miles long. So sometimes what we've seen, we've caught fishing gear on that cable before. We've had boats who don't listen to our radio call, who want to run across the cable. So we have units on the cable called digibirds, and they fly the cable through the water column. So when that happens, we send the cable down deep, down to 40 meters, in the hopes that the boat can then cross and hit the cable. Any more questions?
What's your specific training?
So I went to, I'm from Michigan. I went to Jackson Community College, just south of Lansing. And then I went there for 2 years, and I went to Michigan. And I have a bachelor's in science with a geology degree. So I went to the oil and gas field for 20 years, and then I came to Columbia to work here at the university. But I work with people with all sorts of different degrees, technical backgrounds, certifications. There's many different paths to sort of get here.
What's your specific responsibility on the ship?
So what I do, so as I mentioned before, so I'm the chief science officer. So I work for Columbia University on board this boat, and we have a lot of different scientists from all of the boats who come here. So we don't have the same scientist all the time. So for a particular science mission, we'll have anywhere from 4 to 5 up to 20 different scientists. So we'll usually have 1 or 2 professors or researchers, and then we'll have their students from PhDs all the way down to undergraduates. So when they come on board, I work with scientists to make sure that they can accomplish the mission that they want and they can obtain the goals that they set out with. So when a lot of the scientists come on board, they know how to process the multi-beam data, how to look at the multi-beam data, but they don't really know the nuts and bolts, sort of how to run the software to acquire the data and how to troubleshoot. So myself and the other technicians on board, we work with the scientists to make sure that they can meet their sort of goals that they started with.
How long is a typical mission? Is this like ongoing for you all the time? You're just picking people up and dropping them off, or do you get breaks where you're not on the boat?
So the boat works, it's at sea about 280 to 290 days a year. So we work 6 months a year that we're on the boat, and then we're home 6 months a year, more or less. So we have a rotation. So I'll be on board the boat for 6 weeks, and then I'll go home, and then I'll come back. But the boat works all the time. So there's a few times of the year, obviously, where it's at port. As I mentioned, it's 280, 290. We're at port for a couple of weeks as we maintain the boat, as we do maintenance, as we crane equipment on the boat before we sail again, and then we head off to do the next mission. Yeah. So, for example, this port call in Cape Verde was only a couple of days. So we're going to sail down to this work area that we're going to be, and then we're going to work there for 4 days. And then we're going to sail back to Cape Verde. We're in port for another day or two before we then leave and come back to the East Coast. And then in May, we're going to sail to the western side of the U.S., to the Pacific. And when we do that, we go through the Panama Canal.
What's the craziest ship you've encountered?
The craziest ship? Well, that's a good question. So, obviously, offshore you see a lot. So you see the mega tankers. You see they're called ro-ros, roll on, roll off. That's how all the cars get sent to the United States. They're huge, all the way down to small little fishing boats in the middle of nowhere. So we've worked in Asia, and you could be 20, 30 miles offshore, and you see a boat that's no bigger than a boat that you'd see in a pond or a lake down the road.
No pirates?
So we were recently, they exist. When we were recently in Cape Canaveral, we saw the Ocean X barges, where that they send the barge out where the rocket lands on the barges. So pirates are a thing depending on what part of the world you're working in. So there's no longer the Pirates of the Caribbean, but there are pirates offshore of Africa and over in Asia. And when we sail in those type of waters, we have to do what's called as hardening the vessel. You have to harden the vessel. So what we do is we put barbed wire all around the boat. On the outside, we secure all the doors, and we only have access to the vessel through one door. Everything else has been locked down, so we can control the access a lot better. And then, as I say, we have the barbed wire, so nobody can come alongside, or at least hopefully nobody can come alongside. You can get on the boat that way. Yeah. Any more questions?
Questions? It's gonna be a late spring. We just had a bunch of students leaving because they have spring sports, so I'm kind of letting everybody settle here.
Okay. Yep. No problem.
So you said this cumulative work you're doing goes to, what did you say, 2030?
So some of the work goes to, it's not, Seabed 2030 is sort of a mission or a plan to have all the data or all the oceans mapped by 2030. But the data itself goes into, it's sort of a public repository of data that anybody can use. So there are different data centers that sort of hold the data, but it's available for the public. So yeah, so the seabed data, the multi-beam sonar data that we acquire on the transits goes towards that. And anytime we sail, we have the sonars running.
I also teach biology, so I'm kind of interested in some of the wildlife research that's been done off the ship.
Yep. So as I mentioned before, we have the protected species observers on board. So there's a group, 4 to 5, sometimes 6. For example, when we worked up in Iceland, we had 8 of them on board because the daylight hours were a lot longer. We had 20 hours of daylight. And what they do is they come on board. They have a observation tower. On the video, you would have seen it, but it was. Let me see this. Yeah. So you see, there's like a sort of a tower up top here. So you see the green crane, and forward of that you see the tower. So the protected species observers, they work up there. They have binoculars, they have cameras, and they monitor the ocean for whales, dolphins, sea turtles, different seabirds, and they have a report every week. And at the end, they have a sort of a job or a cruise report that they send in to the National Science Foundation, and that data is used for wildlife sort of tracking biology movements. You know, when it's the whale migration season, how far up the whales have moved. So all that different data is used for that. So we have 2 types of way that we can sort of see or observe the wildlife. We have visual, but we also tow a small cable behind us that's called PAM. It's passive acoustic monitoring. And that small cable has hydrophones in the cable. And we have software that runs that we can track the frequency that whales and dolphins vocalize at. So they're able to, if a certain whale makes, a vocalization, they can record that, and they can also triangulate where that whale or dolphin is at relative to the boat. So they use that data as well as part of their final deliverable to the National Science Foundation.
You do any water quality work off the ship?
Yep. So a lot of the work that we do is mostly geophysical type work. So we do the seismic, we do the sonars, we do the gravity measurements, we do magnetic measurements. But we also have some science missions that are more oceanographic based. So we have a unit on board that's called the CTD, and we send that down, and we can take water samples up to 10 liters per bottle, and we have 24 bottles. Let me see the picture. No, I don't have it right now. But we have 24 bottles that go on it at 10 liters a bottle. And there's different type of instrumentation on that package as it goes down to the water layer. For example, that we can measure the temperature, we can measure the salinity, the speed of sound to the water. So we have different type of instrumentations on that package that we can then get data. On board the boat, we also have a system that's called a uncontaminated seawater system. So we pump water through instrumentation all the time to be able to get the temperature, the salinity, the PCO2. We have different weather machines on board that were actually this screen right here behind me. So this is the weather screen. So this data goes to sort of the global aggregate weather information through the through NOAA. So when we look at different weather programs, the weather observations that we take on board gets calculated into that, for example, like wind speed, air temperature, humidity, those kind of things.
I guess that's about all the questions we have right now.
All right, good. Well, I appreciate you taking the time. Fortunately, we had some some internet glitches there at the beginning, but that's life on a boat. So I appreciate it, and I thank you very much, and we'll sign off.
Thank you.